Hello, friends. Welcome back to another session of DBMS. Today, I'm going to discuss how indexing works in a DBMS and demonstrate its impact on search performance. Indexing is a crucial technique used to speed up data retrieval, reducing the need for table scans. So, we'll be comparing searches with and without indexing to understand how indexes optimize query execution. So, what is indexing? Indexing is a database optimization technique that improves the speed of data retrieval operations. It works like an index in a book, allowing Oracle to locate data quickly without scanning the entire table. When a query searches for data, the database can either perform a full table scan, like which is checking each and every row one after the other, or use an index wherein it directly jumps to the required row. So, this is indexing. So what are the various types of indexing in Oracle? So the default indexing type in Oracle is B tree index. And then we also have unique index, composite index, and bitmap index, function-based index, reverse key index, and clustered index. I'll be showing you B tree index today, which is the default index in Oracle. What are the advantages of indexing? So faster query performance, speeds up select queries, and especially on the large tables. So efficient searching improves order by, group by, and filtering conditions, and optimized joins. So through indexes, you get optimized joins. So wherein the performance of joins will be better. And then reduced disk IO operations. So the fetches data with fewer reads and so on. So these are the advantages of indexing. The disadvantages of indexing is like it slows down the write operations. So the write operations make modifications to the table, like the insert, update, and delete commands, which take longer because indexes must be updated. And then it consumes extra space because you need extra storage for storing the indexes. And then not useful for the small tables because on the smaller tables, like even if you perform the table scan, or you perform the index scan, it doesn't make much difference. So the difference comes only when the data set is too big. And over indexing can hurt performance, like too many creations of the indexes will slow down the database instead of speeding it up. So these are the disadvantages of indexing. And when to use indexing? So when searching large data sets frequently, so we use indexing. When filtering data, we're using where conditions often, then we also use indexing. And then when sorting, using order by and group by on the large tables, we use indexing. And indexing should be avoided on columns that change frequently, timestamps, etc. This is how we create index in Oracle. So create index and then the name of the index on table name and then the column on which like we want to create the index. So say for example, I want to create index for S name column of the sailors table. So this is how I'll be doing it. So I'll say create index and then the name of the index on sailors table on S name. Okay, right. So if you want to create composite index, which is like combination of 2 or 3 columns together. So this is how I create. I say create index, then rating age index on sailors table, and then the columns together that I want to create an index is on rating and age. So this is how I create composite index. So no need to create an index explicitly for primary keys because Oracle automatically creates an unique B tree index for them. So primary keys automatically become indexes for the table. So you don't need to create explicit index like this. Like you say, for example, in the sailors table, SID is the primary key. You don't need to create index SID name on sailors, which is SID. So you don't need to do that because Oracle implicitly itself will create indexes for the primary keys. For the non-primary keys only, we'll be creating the indexes. So this is your DBMS experiment number 12. So create a table and perform the search operation on the table using indexing and non-indexing techniques. So let me tell you how I'll be solving this. For this, like first I created the sailors table and inserted data into it. And then I'll show you how to search the table using primary key, so which is indexed access and which is implicit indexing. Then I'll search without an index and will show you how it performs the search on or table without an index, and then create an explicit index on SNAME column of the sales table, and we'll show you what type of scan it will do on such type of index. Okay, right. This is your DBMS lab experiment number 12. So to create a table and perform the search operation on the table using indexing and non-indexing techniques. So I'll be showing you to create a sales table and insert data into it. So this is the first thing I'll show you. And then I'll show you how to search the table using primary key. So I'll be making SID of the sales table as the primary key. And then we'll show you how it will scan the table on the primary key. And this is like implicit indexing. And it will be an indexed access because SID is the primary key. And as I already told you, Oracle creates an implicit index for the primary key. And then I'll demonstrate how to perform a search without an index. So there won't be an implicit index and also an explicit index. And I'll show you what type of scan it does on a table without an index. And then I'll also demonstrate explicit index for you. I'll create an explicit index on SNAME column of the sales table, and we'll show you what type of scan it does on the table. So the sales table has got SID, SNAME, rating, and age, and I did not make SID as the primary key. So this is how I'll be demonstrating explicit index for you. And then this is all are the tuples that the sales table has. So let's get started with the demonstration. So as I already told you, this is how I created the table. So SID, integer, and primary key. So SID is the primary key here. And then I inserted all this data into this particular sales table. Okay, right. So after I have finished inserting, so this is what I need to write. So I need to say explain plan for select star from sailors where SID is equal to 32. So I'm performing a scan on the table with the SID, which is the primary key. And also I need to say select star from plan table. So we'll be seeing what is there in the plan table now. Okay, right. So I'm running the query and we'll see the script output now. So you can see that this is the script output, and as you can make it out that so in the operation, so this is the plan table. So inside the plan table, it is saying me that there is a table access, and the table access is performed on the index. Okay, so it is an indexed scan. So, and by index, which is some row ID, and then it is a unique scan. So that's what it is telling us that. So by this, what we understood is that Oracle has implicitly created an index for you, and then it is performing the table scan on the index. Rather than doing the entire table scan, it is doing an indexed scan. Okay. Now what I'll do is I'll drop the table because I want to take off the primary key from the table. So I have dropped the sailors table, and then I'm creating the sailors table once again. But wherein I have removed the primary key over here. So SID, integer, and SNAME, and then so on, wherein I haven't made any column over here as the primary key. So let me insert the same data into the sailors table. So I have inserted the same data into the sailors table, but there is no primary key now on the sailors table. So let me write the same query. So which is explain plan for select star from sailors where SID is equal to 32 and select star from plan table. So let us see the plan table once again where there is no primary key. So this is the plan table, and you can see that inside the operations of the plan table. So it is telling me that there is a table access and the table access is full. In the previous case, like it is telling me that the table access is on the row ID, which is unique and which is on the index. By this, what we understood is that if there is a primary key, Oracle implicitly creates an index, and if there is no primary key, then it will do a full table scan. So I'll show you how to create an explicit index for you. So I'll keep the same table and we'll create the index now. So since there is no primary key, I'm creating index for the SNAME. So maybe SNAME is the frequently searched data from the sailors table. So I'm giving an index for SNAME. So generally for what column we'll be creating an index is like whenever there are frequent queries coming up for that particular column, So we'll be creating an index for that particular column. So say, for example, for the sailors table, S name is the most frequently queried column. So that's why we are creating an index for that particular column. So create index sailor name. So this is the name that I have chosen for the index on sailors table for the S name column. So let me hit on the run button and see whether the index has been created. So you can see index sailor name has been created. Okay, so now we'll run the same query, but here I'll be saying, instead of saying SID is equal to 32, I'll say S name is equal to Brutus. And make sure that the name here is exactly the name, because this is case sensitive. S name is case sensitive. Whatever name that you have given there should exactly match with the case as well. So I have given Brutus over there. So with B capital and all that. So I'm giving the same name here, else it won't perform the operation. So explain plan for select star from sailors where S name is equal to Brutus, and select star from plan table. So let us look at the plan table now and understand whether Oracle is creating an index for S name or not. So you can see that Oracle has created an index, and now it is saying that table access with the index. In the previous case where there is no index created at all, neither the implicit index or explicit index, in that case it is saying that table scan full. But now since we have created an index, it is saying that table scan index. Okay, right. So that's the difference that we get. If you no longer need the index, you can drop the index with this command, which is drop index and then the name of the index, just like the table how we delete. So before dropping the index, let me show you like what Oracle uses as the default indexing. So for that, I have written the query as select index name, index type from users indexes. So these are the user defined indexes will be kept in a table, which is called as users indexes, where table name is equal to sailors. So I want to know like what are all the indexes that have been put on sailors table. So for that, I'll be using this particular query. Okay, right. So same like how we write the select query, but on the users indexes. So this is the users indexes table, and I just wanted the index name and the index type. So there is only one index on the sailors table, which is index sailor name, and the type of the index is normal. So what does it mean by normal? Normal means that the default index that Oracle uses, and the default indexing type that Oracle uses is B trees. So normal here means B trees. Okay, right. So let me drop the index. Okay, so I have dropped the index. So with this command, drop index, index name. So when I execute this query, it is telling me that index sailor name dropped. Okay. So that's it, friends. So this is all about how to create explicit indexes in Oracle. I have demonstrated what are implicit indexes and how Oracle performs a full table scan if there is neither implicit or explicit index. And then I have shown you how to create an explicit index and also drop the index, and what is the default indexing type that Oracle uses. If you have found this video to be helpful, like, share, and subscribe, and also comment below. Thank you for watching.